Yes, okay. Good afternoon, everyone. Let me share my screen. We're now, let's say, this afternoon in the technical session recommendations, following the sessions that you had yesterday and part of today. Advances in InSAR theory, methodological innovations, where we had 3 sessions. Atmosphere and Ionosphere, data product and services. All the session chairs of those sessions are with us today. It's important to note that for today's session, we're eager to receive your inputs on recommendations. We're not general, let's say, not only towards ESA, but also, let's say, towards both other space agencies, but as well, let's say, to the overall community as a whole. Try to see where we could go, and let's say, to try to push the envelope even further than what we've seen over the last couple of days. So, without further ado, let's say I would like to introduce, let's say, the panel, the panel chairs. We have Fabio Rocca, who was chairing the first session on advances in InSAR theory and methodological innovations. We have Howard Zepker and Eric Fielding. We're doing the second session of the same topic, and Ramon Hansen, who was doing the third one. Then on Atmosphere and Ionosphere, we have Francesco De Zan, and we have Paolo Pascali and Mario Costantini, who were on the data products and services. So we go in this order through the sessions, and if you have a question, you can raise it on the WebEx chat, or if you want to interact directly, let's say, you can also ask to be unmuted, and the conference organizer will unmute you, and you will be able to directly interact with the session chairs.
You can raise your hand.
Yes.
We will unmute you. Yes.
Excellent. Okay, good. Okay, so then we go to the first part, actually, the first session, which was chaired by Fabio. I can now, I think, maybe move into.
So good afternoon,
yes,
everybody. So in my session, we had 3 subjects, and they were bias, ways to predict and correct unwrapping errors, and InSAR. So I'll go through the subject, trying to summarize what was said, and finally I'll introduce 3 seed questions that could be of interest for everybody. I don't know. Anyway, I will start proposing them. So let's move to the next slide.
Yes, can you move a bit close to the microphone, Fabio?
Yeah, move to the next slide, please.
Yes, I'll do. Yes.
Okay, so the bias. Okay, the question of bias was discussed by Homa Ansari and Jujie Zhang, and they both agreed that the fading signal is there, and this compromises the reliability of InSAR-derived deformation velocity maps. Then what can we do about it? Either it can be suppressed with long-term triangulation. In other words, if it's fading, so let's look at longer-term elements, and we can correct for it, or it can be measured and corrected. This was the Zhang proposal. Now, I received from Homa Ansari a proposal for an interferometric time series product with reduced stochastic and systematic phase errors. And this is a recommendation. And so I'll go through this recommendation because it's they are recommending Homa and Francesco De Zan and Alessandro Parizzi and others are recommending a new intermediate product level for InSAR. That is the reconstructed consistent interferometric phase series. Next slide, please. Okay, I'm passing their recommendation. So is this what they are proposing? Because this product will contain the physical signals, but should correspond to atmospheric variation and surface displacement, reduce the interferometric phase bias, reduce the amount of interferometric data from the original pairwise interferograms in the data stack, and okay, optionally subsample interferograms, just getting rid of the short-term interferograms, ease the data transfer and provide a unified input to the user community, and finally enhance the reliability of InSAR for displacement analysis, specifically for the retrieval of the deformation velocity maps. So this would be a product, and so there is a recommendation proposed by them. So I just leave this as a proposal, their proposal of a recommendation. Now let's move to the next slide, please. Now, then we have also another group of two talks discussed predicting and correcting phase unwrapping errors. I have to say that I heard the paper by Philip Conroy, and I was surprised because really he was proposing a very simple but very effective methodology to identify areas in a very soft terrain as the one who's where is he working, that is Rotterdam, and in general the soft terrain from Holland, where really they can have very fast rain uplifts due to rainfall, and this could lead to phase unwrapping errors. So a very simple neural network based on the day of year, the rainfall, the soil type, can group terrain non-locally, totally non-locally. So all through a burst, I would say, they are grouping different terrain location, but that behave basically the same way. And so basically grouping them, he was able to understand where the actual conditions led to phase unwrapping, where it did not, and so basically could have a very nice phase unwrapping tool, just teaching to the bad guys, the bad locations, what the good locations did. I enjoyed very much that talk, and basically this is something that is also divided by the other paper by Zhang Junyun, who's also studying the problem in a completely different context, because basically he was evaluating possible causes of phase unwrapping errors, ionosphere, troposphere, not actually in soft terrain, but any kind of phase unwrapping errors, but again, non-local. So you have non-connected terrains, both accepting or getting the similar effect of unwrapping errors, and identifying the cycle skip just by similarity and connecting for them. So really this is two ways of doing the same thing, that is phase unwrapping, basically looking at non-connected areas of the terrain and combining this information to get this phase unwrapping error. It was an interesting talk. Both were interesting talk, and they will lead to maybe to a question. Finally, let's move to the next slide. Then a completely different argument, and this was Nysar. We have the author here also in the panel, so he can say more. But basically, he proposed a random dithering of the SAR pulses to widen the interpulse interval at random. The impact on the interferometric coherence is proven to be small, while the widening of the swath is quite significant. So basically, the idea is, why don't we study new systems, like could be formation. This is my point, but his point is Nysar, just getting rid of a few pulses. So trading additional noise due to the, let's say, randomness of the formation, randomness of these pulses, but this additional noise could be acceptable for interferometric application because they are extremely robust, and therefore few pulses are left, or the non-exact positioning of the formation, or the interaction between the different sources in SIMO and in MIMO, all could be sources of errors. But as the interferometric application are robust, the advantages in terms of extended swath in the case of these are, but higher reliability and lower cost could be significant. And though we move to the next slide, to my final slide, the seed questions. This is related to the bias. And my question is it better to correct for the bias as is being proposed by Homa and Francesco, or is better to remove it? And actually, it's the contrary. They want Francesco and Homa proposed to remove it, whereas Jugier was proposing to correct it. So, but my point is, we should go for more understanding. There were more papers and also posters on the same topic. And my question is anyone using Sentinel-2 data too? Because actually they could help, because they are basically, their timing is exact. And so really to look at the greenery from the green channels of Sentinel-2 could also be useful. Anyway, this is my question. Then the second question is phase unwrapping support. This is important because basically we are understanding, and I think that we have several questions going into the same direction. We have support of additional information, basically metadata. And then they are locally, however, connected. So could they be part of the proposed geocoded image storage? We heard this burst storage, geocoded burst storage, and there we could have all sorts of metadata and additional information. Rather than preparing, let's say, ARD, that is data already processed, good for everybody, I would say, why don't, at least, it's an interesting question to discuss. Should we augment the metadata, so helping people putting together all the information, additional information we have, or should we combine all this information to get our best understanding and let the users look for the tools rather than giving them the tools in their hand? And finally, random SAR. This is also an important topic. And here my question is, how significant is the risk of detritus? In other words, are we CubeSARs and formation the inevitable future? Are we bound to look at these systems because it's too risky to put all our eggs in the single basket of a big satellite rather than spreading our risk into CubeSAR, into formations, so that detritus risks are somehow reduced? So, and with this, I'm through with my session. Thank you.
Thank you, Fabio. Does I notice you have put already a recommendation and actually see the questions?
I passed the recommendation. It's not mine. It's coming from Homa and Francesco.
Okay, it was directly coming from the, yes.
Yeah,
okay.
But since they gave it to me, I was bound to continue to propose it.
Okay, excellent. Okay, that's because the recommendation, if I correct, it was right. Let's say it was on the actual CIMO and MIMO systems. No, this is the one you mean.
This is just to study Nysar system. In other words, the recommendation is connected to the inevitability of the detritus risks. In other words, are we bound to study systems that are risk prone or risk independent? Is the reliability due to detritus an important element in the study of new systems, or maybe it's too early for that? This is a question. It's more a question than a recommendation.
Okay, good. Okay, thank you. Are there any questions already posed by the audience?
Not yet, Bjorn.
Okay, not yet. So this is the time. If you have any questions on this, this will be the time to react. I do have something on random SAR, Fabio, and I think you are probably the one to also, let's say, to at least answer this part, let's say, and I guess as well, let's say, Howard, if he's still there, and Eric, maybe could as well contribute to this as well. So I would invite all the panelists on this. Is this not, let's say, that if we go, let's say, from SAR as we know it right now, which is relatively exact science, to make it to something that is more, let's say, then become more a probabilistic nature, that you have to be lucky that your formations are flying all, let's say, are good enough, let's say, for all the time, in terms of, let's say. So is this not the risk of going towards these random SAR formations? This is a question I would like to ask, let's say, to the panelists, and maybe Fabio to start this start the discussion on this.
Do we want to do this now, or do we want to do after all the panelists have spoken, so that we know exactly how much time we have?
No, we do it now. We do it now, I think, because then we have to move, let's say, in a couple of minutes, we have to move to the second part already. So, yes.
Well, my opinion is, okay, so really,
one thing that's important is that the dithering is going to be used by Nysar for the sweep SAR mode. So this is something that's already being planned for operations.
Yes, but this is dither SAR, no? Yes, exactly. Yeah, but we're talking more about random SAR on the CubeSAR systems as well.
So I would add to that. I mean, not only is this being used for Nysar, so it is important to understand it now at some level, but as we are moving to systems where it's harder to synchronize perhaps everything, and where we're going for these very, very wide swaths, we end up transmitting when we want to be receiving, and we end up with data that have blocked areas in them. We know about that, and we know about ambiguities and things. But the idea is that we can still form images. We don't have to form images exactly with convolutional processing as we have done before. We can either resample data onto a regular grid, as we all know, or we can simply back project the data and not really be too concerned about where those things are. And because the processing has gotten very, very cheap and our ability to measure things has gotten very, very good, then this, I think, opens the way for systems that can be collections of all these other kinds of smaller platforms and such, as Fabio mentions. So I think this will be something that we will be much more reliant on as we go forward.
Yes, this is understood. Yes, yeah. This is a good point indeed. That we already with the systems that we're going to launch in the next couple of years, we'll be able to at least gain more understanding how this will work. But of course, there's a difference between having something that is still a single system and where, as soon as things become really fragmented SAR systems, then we're really pushing the envelope even further. Yes.
Well, but that's what we like to do. So
yes, I know.
That's what we will do.
Yes. Okay. Anything else, Fabio? You want to raise at this point, or someone else from the audience?
More or less, I just gave my questions, and so I will be happy to hear the other participants, the other panelists.
Yes.
If you want, I can comment on the bias and removal. So
yeah, Francesco, why don't you?
Yes.
Yes, I was very impressed by this couple of presentations showing with very simple models how they could remove the bias. But still, I think if we have the long-term coherence, why shouldn't we use it? Like if it's there, and if we move towards L-band, this is even more there. So I think we should use it. And having the long-term coherence avoids anyway some integration, passing from short temporal baselengths to long temporal baselengths in the time series. So in my opinion, we should exploit this long-term coherence and not risk drifting also for other reasons that we don't know yet, especially thinking in the future in L-band. I think, but of course, we also want to understand it and maybe exploit it in different ways. And so it's also nice to have little models that can correct it. And so that's it.
As a question from the audience from Yassir Maghzoudi, you can talk, Yassir. Thank you.
Hi, can you hear me?
Yes.
Yes.
Yes, we can.
Yeah, hi. My name is Yasser Maghzoudi from University of Leeds. And so we were also working on the topic of phase bias, and actually did several experiments, and we were looking for some solutions for a mitigation strategy. So based on the experiments that we did, actually, in case of the decorrelated regions, such as the forests or agricultural areas, maybe these are only the short-term interferograms that can maintain the coherence in the time series. So maybe avoiding all these short-term interferograms because they are more susceptible to bias is not a good idea. And so maybe just trying to find a solution to correct for the bias in the short-term interferograms would be a good idea, especially in the decorrelated regions.
Okay, thank you. Any feedback on this from maybe Francesco? Something to add on this?
No, I think I understand.
Yes.
We have to also wait the needs of the short term coherence when there's no long-term coherence. So maybe we have to have both somehow. Like if we don't have this long-term coherence, we need to have corrections, model-based corrections, and which are extrapolating to longer baselengths. But if we have the long-term coherence, I think why shouldn't we use it. Like so.
Exactly. Yes. Yeah. And the issue on the use of the Sentinel-2 data, how would you envisage this, Fabio?
Well,
said
I wonder,
using the green,
it's, you know, phase is not necessarily irrotational. So the covariance matrix is not irrotational, but it would be interesting to look also at I would say, the equivalent of the closures in the greenery of the vegetation or in the look of the moisture. I think that looking at the Sentinel-2 data on the same locations at the same time could be of interest. I haven't been seen done as yet. Maybe Francesco could tell me, maybe you did and we didn't show, but it would be interesting. We heard many discussions also from the French on the histograms of phases, but no one talked about amplitudes and I would say amplitude in the visible spectrum. So what would you say, Francesco, said?
No, we haven't looked at this. We were looking at land cover and maybe indirectly to.
Yeah, land cover has not the timings, whereas Sentinel-2 has exactly the same timings. Yeah. I would say that looking at the triads in Sentinel-2 could be of interest, just to see if you have a change of color or something.
Yeah, thanks.
Yes, and of course, it's getting more and more. It's getting more easier for all of us, let's say, to also combine these data sets. So I think we're all working as well towards this to combine, let's say, to look at synergy at data.
Yeah, that's the point. In other words, geocoded data sets at what we want. So we will have in the same locations, Sentinel-2, Sentinel-1, all the satellites, and the timings will be then the key point to interpret the triads.
Okay, I think we have to move on, let's say, to the next part, unless there's something else on the phase and wrapping support we still need to want to mention there. Fabio, is this something you would be able to send to transfer into recommendation, the phase and wrapping support question?
Well, I think that the recommendation is really basic of the presentation that was done. I think Mario will tell us about it. So the geocoded image storage. This is a general idea, and in the geocoded image storage, in the metadata, there could be some, let's say, flags that could tell, look, this area is prone to phase and wrapping errors during summer. This is I would say, the Dutch part. Or this area could be prone to phase and wrapping because ionosphere, not but big terrain slopes, and this would be the case of the other presenter. But certainly in the metadata, the flags for possible phase and wrapping problems could be of interest.
Yes, I would agree. This could be a viable way forward. Yes. Yeah.
Just a simple way, rather than going the whole way of doing it, creating tools, but at least offering metadata that could be of interest.
It could indicate to the users this is an area you have to be a bit more careful with.
Phase and wrapping prone. It's too hilly.
Maybe what I could add about this, and also about the previous point about the bias correction. You know, the risk is that we end up with very complicated situations, metadata corrections, and so on. So I hope, you know, we will not end with a situation not too complicated. So we should try to find simple methods that works. And even though I understand that you know, external information can be important, but we should try to keep things simple, as simple as possible.
If I could just interrupt with one suggestion. There was some work done some time ago at DLR looking at the propensity for phase unwrapping errors as dependent on things like topographic slope and other uncorrected fringes. There was a paper that it was Baumler and I can't remember who the co-authors were, where they came up with a model relating some of the coherence and some of the terrain factors to the probabilities of phase unwrapping errors. So some straightforward models like that might be some good flags to include in this kind of a product. I think it's a good idea to put it in if we can do it.
If you're looking at the Himalayas, you're going to have trouble.
Excellent. Okay, good. I think we move on now to the next session, which was the Advanced in InSAR Theory, Methodological Innovations. Actually, the second one shared by Howard and Eric. So, yes, please take me through it.
Right, thanks. So I'll go through a quick summary of what was presented, and then Eric put together a list of seed questions. So we'll switch over to him to do that part. So there were several papers in this session. They covered a variety of things. One was use of range offsets rather than phases to measure displacements. The ability to take 1D measurements and infer 3D displacements, a new suggestion for using machine learning tools to look for events in an automatic sense, and then increasing our noise covariance modeling capability. So if we go to the next page, next slide. So with respect to these range offsets, there was a paper by Zhang who proposed to use range offsets rather than phase for measuring displacements. The advantage of this, of course, is that you don't need to do phase unwrapping, and that way we avoid those kinds of errors. However, it's intrinsically a noisier measurement than the phase measurement, and so you need to do a lot of averaging if you're going to get the errors down to something that is useful geophysically for other than major events. So in this paper, they were able to show that if the deformation is relatively low spatial frequency and at a constant rate over a long time, then you can do a lot of averaging, both temporally and spatially. And they were able to derive a map of displacement along the San Andreas Fault down at the better than 1.5 centimeter level. So it certainly is possible to do this. In theory, they showed that you could approach millimeter level errors, and this perhaps gives us a way around some of the phase unwrapping problems that crop up from time to time. Anyway, it looked like it was a promising thing for us to look at. We need to really understand how we do those different trade-offs, but it definitely is promising work. Next slide, please. And then there were a couple of papers that looked at this idea of we only are measuring radar line of sights. We're trying to infer 3D displacements, and everybody recognizes that with ascending and descending tracks, you get 2 lines of sight. So you get 2 1D measurements, and you're still trying to look for 3D displacements. And there were a couple of papers that addressed various aspects of this problem. One from Jihong Liu looked at the use of geophysical models that modeled 3D phenomena, and they project them into the 2 available radar line of sights, and saw that there was a way to get, you can constrain these models. You don't constrain them perfectly, but it does, in fact, help rule out the variety of different kinds of motions that would be consistent with the measurements. And then there was a paper that looked at this from a very different aspect by Witzke. No, back please. It's still on the same slide. Witzke Brouwer showed that looking through the past literature, there are a lot of examples where people either made assumptions to deal with how to go from 1D measurements to 3D displacements, or described what they did in ways that were not really very precisely laid out, and so they could be a little bit confusing to the readers. And this was actually what I thought was a really interesting part of this, is how we as radar specialists are able to communicate with both our peers who are perhaps specialists in a different area, or even people who really don't understand what we're talking about when we say phase or fringe or whatever. And so I guess you have to read this paper to really appreciate it, but I would like to point that out. And so the recommendation that came from this is that researchers need to carefully and fully explain the results and the assumptions that are used, and often that hasn't been the case. So I think it's something that we all should look at and think about. Next slide, please. Then there was a paper by Ansa Shakil, who looked at machine learning for anomaly detection in InSAR time series. This is driven by the fact that we all have so much data now and so many long sequences. A person can't look at 4,000 interferograms and try and find what they're looking at. And so we're going to have to move to something where machines can be able to do this. And she proposes a method that estimates the background noise of a local set of, in fact, they use typically 9 series measurements, estimated the background noise and checked to see if one of the measurements out of that small sequence deviates a lot from the background noise. And in that case, that can be flagged as an event. And so this does seem like a good problem for machine learning, beyond the usual, well, I don't know what I'm doing, so I'm going to throw everything into a machine learning algorithm and it's going to solve it for me. I mean, we know that doesn't work, but this seemed like a good approach to trying to identify some of these different events. And they showed that they were able to find both some real events and also some data anomalies that just had to do with places where the signal was lost. So I thought that this was actually quite interesting. And then finally, one more paper on the next slide, please. Had to do with understanding our noise covariance modeling a little bit better. There have been a few papers, as you know, on this by some of the authors that we've even talked about in the previous session. But Sami Esfahani presented an approach to making these covariance matrix estimations, and made a good case that better characterization of the noise will help us not only understand the characteristics of the noise better, but also it gives us the right weight models, so we can do more accurate inverse solutions from these data. So with that, maybe Eric can take it and talk about the discussion items.
Yeah, one of the things that came up that in the dense offsets or pixel offset tracking is that that Sentinel-1 TOPS is great in the range direction, but the azimuth resolution is much coarser. So for the TOPS mode, we actually the pixel offset tracking is not very effective for, and this may be change with other satellites. So that's one of the things to think about with dense offsets or pixel offset tracking. So I think in the future we maybe look at other modes to get better resolution in the along track direction of deformation. Maybe is there any other? Then there was these time series analysis methods, how to best extract the the statistics, the two different things, the machine learning approach and the data analysis approach were both seem to be very helpful. And I think combining that with the elastic modeling might help to better understand the three-dimensional deformation. And then I think the other question is how do we best explain how the line of sight measurements actually relate to the ground deformation, and that needs to be we need to reach some kind of maybe have a standard way of explaining that, because Vitska explained in her talk there's too many papers have been written with very imprecise and even incorrect ways of explaining how the line of sight deformation can be converted to an estimate of vertical deformation. So that's something that I think it's especially confusing for the non-expert to take these measurements and think that they know what it means for vertical, but they actually don't know what they're actually measuring.
Okay, thank you, Eric and Howard for the introduction. Is there any questions from the audience? Any hands raised on the topics that have been discussed in the session chaired by Eric and Howard?
Not yet, Bjorn, but if attendees can also use the Q&A panel.
I have one question for Eric.
Yes, please, Fabio.
My question is, how comes that no one practically ever used the left-looking data for the north-south component? Basically, if you look at this line of sight, it should more or less reduce the singularity of the matrix. But I haven't seen anyone doing that. Do we have a rationale for that?
Actually, one of the talks did use some left-looking data acquired by the ALOS 2 satellite over Japan to do the three-dimensional deformation. And of course, we have the Nysar mission, which will be an entirely left-looking mission, which will, in 2 years, provide a different look direction for the whole Earth. So that's something that we can look forward to in the future. Is a fully left-looking mission. It can be combined with the right-looking missions that are commonly used. I mean, I don't think they can just take the Sentinel-1 satellite and turn it around. It's not really
but Cosmo can do it, and TerraSAR can do it, and RadarSat can do it. So it's a question of money. It's not, and certainly that's the other question. Do Nysar go into the left-looking part for that, or there are other good reasons?
The Nysar went to left-looking to be able to image Antarctica.
Oh yes, sure.
I mean, that was one of the key mission objectives, and we had initially designed it to do left-looking part of the time and right-looking part of the time, and then we realized that that was just going to by switching back and forth, it would mess up all the time series. And it was better just to keep it always left-looking. We lose some coverage of the Arctic Ocean, but Sentinel-1 and other satellites are all getting good coverage of the Arctic Ocean, so we decided to concentrate on the Antarctic.
Sure. So the north-south problem is going to be solved soon, because with all this flurry of left-looking data, it's basically the problem is solved. Do you agree with that?
Yes, I think so.
So it's a question of time.
Bjorn, please have a look at Q&A, because there are some questions from audience.
Yes, okay, have a look. Let's see how I can.
Yeah, somebody asked about the amount of time it takes to change from left-looking to right-looking. With the Nysar satellite, it takes a whole orbit because it's a huge reflector system. And it's not something that we can do. It's not a nimble system. Maybe some of these smaller satellites like TerraSAR X and Cosmos SkyMed can switch left and
Oh,
right.
they can switch in
more
3,000
quickly.
kilometers, I think.
Yeah.
So it's easy for them. 3,000 of the order of 3,000 kilometers.
Okay. Any other questions? Of course, there's of course also for the getting access to the three-dimensional deformation. Of course, future multi-static systems may also help there, of course. But Fabio was more looking, let's say, for the near future. I think for the systems that are going up now and not towards the end of the decade. We may have systems like Harmony that will be able to assist Sentinel-1 to also, let's say, get access to the north-south deformation. Okay. Anything? There's nothing else. No more other questions. Then we move on to the next part. So thank you. I very much liked as well the part on the machine learning part that was mentioned. Indeed, that of course when applied properly, we will be able. It will definitely help us, let's say, to go through the rich amount of data sets that we have. I think this is an important thing to make sure that we do the physics properly first, and not let's just dump everything into machine learning systems that we all know. Let's say it's not working directly. Let's say have to apply it sensibly. Let's say. Okay, Ramon, your
Marcus was also posting a question if there is any recommendation from the scientific community regarding missions, campaigns, or experiment studies.
Okay, I think we'll cover
the topics that we discussed.
Exactly. Yes. Yeah, we can discuss this as time goes on. I agree. Yes. Ramon, yes, the floor is yours.
Yes. So this morning we had the third part of this advances in InSAR theory and methodological innovation session. And in the next slide, I gave a short overview of what was presented there. So basically, we had 5 presentations. And if you would sum them all together, then I think the main point is that in all of these presentations, the authors tried to get further than either only using the phase to estimate displacement maps or displacement time series, but they tried to add information somehow, and they did that in a different way. So Alessandro Ferretti started this morning, and he demonstrated how statistical analysis of the amplitude of the scatterers could be very useful when you monitor displacements, simply because the amplitude contains information on whether points appear or whether they go away or what kind of behavior they have in time. And he, well, quite convincingly showed that using this information simply makes sense. So the second one by Mark Bruna was information that doesn't come from the SAR observations themselves, but from contextual information. So in most of the cases, we know where images are acquired and at what times. So he demonstrated that you can use this information to improve the interpretation. And he proposed a database approach for that, where to each scatterer, basically attributes can be connected. So spatial attributes that hold for groups of scatterers, but also behavior in time, like, for example, temperature or so on. And using this standardized database system that enabled him to perform queries, and he demonstrated that on a case study where foundations of houses were analyzed. Then Alberto Uffici addressed the point that is also one of the main things from this session, I think, is that whereas we have been looking at a lot of signals which are very correlated in space, so like a substance ball or a big tectonic strain event where there's a lot of correlation in the signal itself, that in fact, if you look at this on point scatterer basis, then no scatterer is the same. Every scatterer has its own behavior. And that it is kind of funny that we're still trying to estimate, for example, a linear velocity to each of those points. And his argument was that we need to have dedicated functional models for each point. And he used the fuzzy entropy for this purpose, and he demonstrated how we can use that to distinguish different types of behavior. A very elegant way of analyzing the data. Then Mario Costantini approached the problem from a different perspective, where he looked at the same geographic area on the ground and then discussed how combinations of different sensors and different viewing geometries could be used. And he explained how displacement sets can be clustered together, and how then you could reach a unique solution by combining these different sensors and geometries. And finally, Jan Yuan discussed the thing that we see with distributed scatterers related to phase closures, and her argument was that a part whereas maybe people have thought that this was a kind of anomalous outlier type of effect, that is an effect that happens all the time and just matters on how you analyze the data, how big your estimation windows are, for example. So they are very common in this case, and that means that they also contain very useful information. So in relation to the discussion that Fabio presented on, for example, the bias in the time series, Jan Yuan here expressed how we can exploit this information actually. So there's a lot of information in the data that we can still extract from it. But these, I think, are the main points. And in the next slide, I added two, let's say, propositions just to provoke discussion. First one is maybe more like a statement. So more and more InSAR products seem to focus on information from single scatterers or single sets of scatterers instead of these wide area processes. And that reshapes our view of the information products, because it means that we really need to decide for each point whether we parameterize that with a linear velocity or as a seasonal component, or something completely different if that is needed by the application. So that's really a different view, I would say. The second point I would like to make also here to stimulate discussion. So there have been several proposals also before on maybe ESA could provide new products from, say, follow-up products from the SAR SLCs and the orbits. And I would argue against that actually. And the way that I see it is that basically the SLC data that we get from ESA and the orbits, that is kind of the main ingredients that we all use to create products. But from these main ingredients, we can make many different products. And which product you make is dependent on the application, on who the person who's going to use it, or the application that it is serving. So in other ways, if we are suggesting that there is only one way to produce one single output product from a certain stack of InSAR data or SAR data, then I think it will be suboptimal in most of the application cases. So my argument would be that if ESA wants to get one step further, then there could be maybe two things which are really very generic. One way is to provide, for example, the co-registration already directly. So we all need our data to be aligned. So it could make sense to co-register and resample the SAR data, the SLC data. And the second thing is that often in that process already topographical information is used. So we basically then can compute the three-dimensional geographic coordinates of each pixel. And that could be an additional meta layer of information. And providing that would be very useful. I think it would speed up different types of application. But the main reason that I wrote this up here is that, in my view, it doesn't really make sense to go for a lot of corrections. So, for example, an atmospheric correction, you could apply one method, but then somebody else will come up with another method, and you get different products. And these products will all kind of circulate around, and then it is unclear which ones are optimal. And optimality also depends on the application. So I think this is a good maybe proposition for further discussion. I'll leave it with that.
Thank you, Ramon. Thank you as well for proposing, let's say, the items for discussion as clear as you did. Any direct questions? I cannot see the questions from my view, so at least the ones that are posted in the chat
There is
window.
There is a question from Mahmoud Arikan. He says, regarding the presentations mentioned, I know Sentinel-1B datasets are excluded from the analysis. Is there any official acknowledgement from ESA about the issue, or should it be taken seriously?
I'm not aware of this. So, is anyone else that could?
Yeah, there was the pixel offset tracking analysis that Zhang Yunjun did, found that there was a systematic displacement between the Sentinel-1 and Sentinel-1A and 1B data. So he excluded the Sentinel-1B from his pixel offset tracking, but it was about a 10 centimeter bias between the two satellites in the absolute pixel offset locations.
Okay.
So that maybe that's something that ESA can address. One of the things I wanted to mention about the SLCs and geocoded SLC is that Nysar is planning to include a geocoded SLC product, which would be actually an SLC that's in a geocoded coordinate system to give a product that people can easily make interferograms out of. I don't know if ESA has ever considered making that type of product from the Sentinel-1 data. I know Howard's actually generated those from Sentinel-1 data. I think Howard had to leave. He had a dentist appointment, but
if I may react to that, Eric, I think what is important in this discussion is that if ESA provides additional kind of layers or so, that it is not irreversible, right? So if, for example, you would do a geocoding using a certain approach or using a certain DEM, and that product would be the only product that is provided, then it's irreversible, then you can go back. So I would argue for a product where simply the SLCs are kept the way they are, but there's a meta layer next to it where every scatter or every pixel in that SLC has a coordinate, right? And that way, people can decide for themselves whether they would like immediately to use that coordinate and have follow-up things on it. But they can also decide not to use it and to perform different types of analysis with it. Would you agree?
Yes, Nysar is actually planning to provide both. That's one of the reasons why the data volume is so extremely large. A geocoded SLC and a radar coordinate SLC.
Right, yeah, that is great.
I would like to comment or to ask actually. There is a question that we will see also in the report about the section on products and service. You know, there is now many products. There is a kind of trend toward creating this kind of intermediate products, platforms and intermediate products. For sure, you know, the final user is interested in information and not to play with the raw data. But I believe the user is not interested in playing with intermediate product as well. So I don't see very much the use of so many intermediate products because the user wants information, don't want to play with data, but don't want to play with intermediate data as well, except academic users. But this is another story.
I object, Mario, because I think you have in mind only a single product, and this is displacements, line of sight motion, and not necessarily is going to be that way for in long term. So really, to stick with meta layers, I would say is more advisable for now. Then we will learn sooner or later what we can learn from radar data, but we haven't done as yet. It took 5 years for Francesco to find that we had the bias, and maybe 5 years more to understand that the bias could be useful for agricultural purpose. So I would say it's too early to, I would say, to freeze the thing into displacement.
No, I agree with this. I'm not saying, many, but maybe this go in the same direction I was trying to say. The situation is still very complex. InSAR product is mature, but not so much. There are many issues to be solved. And so creating, I understand what you mean. So like metadata, this can be for sure useful. But let's say, when I say intermediate products, I mean products that were partially elaborated, partially processed, and we don't know how much this partial process is correct. So probably these products are not useful it's not safe to start from this for the final product. Better to have maybe metadata, and then the one that has to produce the final product to use also this metadata. Anyway, mine, I said at the beginning, is more a question than a statement. I'm not sure, but like Ramon said, it can be dangerous to have kind of partially processed product, which are of which we are not completely sure the quality of them. We are not completely sure about the quality of them.
Can I try to defend the usefulness of intermediate products?
Yeah, sure, Francesco, go ahead.
Yeah, so I believe there are also some sort of, one should also think of intermediate users, like maybe people or actors that could build on top of this intermediate products and add value on top of them. And not everybody wants to start from the beginning and wants to deal with with co-registration, of course, first, and with this huge amount of data, which is problematic for everybody. So if you are able to reduce this amount of data, this is a matter of accessibility, and then there will be actors and users able to exploit, and I think really unleash the potential of InSAR, because here it's still little experts, so little groups still. I think it's very hard to we work with this every day, so we think it's easy. But it's for many users it's super complicated and boring. And I've seen the presentation, a poster by the Descartes Lab. They are producing some sort of course they go to the end, to the deformation, but they are also producing 50-meter grid phases, and they seem to be useful. So this will not cover all users, and some users will want to have will need to start with SLCs, and some users will need to start with L0 even. But not everybody. So the question is there like 80% of the users, or good enough? And I believe it's like this, and I also think it's difficult to discuss and really find out. One can say one thing and contradict, and
just to be more precise about my statement, I agree that there is no need to start from scratch every time. Now, maybe 20 years ago, people started from raw data. Now everyone starts from SLC. But there is a difference, because you have to be sure that what you have done, the process that you have done, the product you start from is good and safe. So the focusing is safe. There is no problem with the focusing at the moment. when we speak with these ill-posed mathematical problems, you can have many different solutions. So it can be very risky. So I'm in favor of intermediate products if these are very safe, no errors, because otherwise we risk to create problems to non-expert users.
Yes. Okay. I can understand both, but I think the main point, and I think is also what Ramon stated, is that we should not, in general, and I think none of the space agencies are doing this, to make irreversible choice, let's say. So if we have a certain phase screen, for example, ionospheric phase screen for biomass products, we will make sure that people will always be able to go back and be able to come up, let's say, with a better ionospheric perturbation, let's say, or correction, let's say, techniques to do this. So I think this is definitely covered for. And also, let's say, on the other hand, as Francesco stated, let's say there are more users, let's say, that are moving into the SAR world, which are not necessarily experts of SAR raw data, or even, let's say, SLC data. So the multitude, let's say, of different products that are coming out, let's say, but then the question is, are this the responsibility of the space agencies, or in general something that will be done, let's say, by the value-adding industry in general? And I think you see things ongoing on both ends in that direction. But the main ingredients, and I think that this will comfort, let's say, Ramon a bit, let's say, that we'll make sure that those ingredients are as pure as possible, so we can keep on making the right recipes in the future as well. On the other hand, let's say, for if we have level 2 products, let's say we have missions that we want to serve up to level 2, even, let's say, you can think about biomass and looking at biomass, above ground biomass products or forest height. Then of course we still have both SLCs, but also, let's say, the level 2 algorithms that we serve to the community. So it's definitely not a replacement, let's say there. Yes, Fabio.
I have one question for Eric. How far are we from getting the map of the faults of California so that one can really combine the displacement, so to have a precise idea of what's really going on, especially now that with these new methodologies, ETAD suppressing the compensating for the earth tides and so on, things should really maybe change again. Do you agree with that? In other words, how far are we from the holy grail of getting the false geometries, say in Southern California, where it probably is most important, but also, I don't know, on the Anatolian fault or so? Because then one could again process things a different way, because you have different groups of pixels that you combine together to better estimate the relative motion of the fault and so on. So how far are we from that?
I think every year we find new faults. When the new fault breaks, in California, we can't do a priori mapping of faults, and we find that there's also a lot of other things that cause deformation in California, especially groundwater, oil extraction, lots of other effects that are causing deformation that we can't need to separate from the faults. I don't think you can a priori determine where the faults are.
So the metadata corresponding to the faults would be also interesting. At least the known faults.
I also should have mentioned that the Nysar mission is planning to provide level 2 geocoded interferogram products as a standard product. So that's another thing that we're planning to do. It's in the product specifications.
I have a question here from Pablo Gonzalez, and he says that I would also suggest for ESA and perhaps NASA and Nysar as well, to investigate if it's possible to generate products that will be more compressed. The rationale will be to obtain some benefits, such as speed up distribution, reduce storage and operation, and so on. And then we have also one comment from the audience that the chairs are not mentioning the poster session and the important findings of the poster session. But this is just a comment.
We didn't have the poster session yet.
There was a poster session today.
Oh, there was one earlier today. Yeah, sorry. I was
Already
asleep.
one today. But the posters are available on Brella, and the summaries of these sessions will be also on Friday. So there, for sure, we will cover all the summaries of both oral and posters. But maybe we can also discuss the question of Pablo about the investigation of possible products which are more compressed.
We are looking at providing subsetting functions, but I don't know of any plan to do compression for Nysar.
Okay, anything? Yeah. Yes, please.
Bjorn,
Yes.
I have a question from the audience from Brad Libras. You can talk. Thank you.
I don't have a question. I'm sorry.
Okay.
I raised my hand by accident. Thank you for all of the presentations. They've all been very good.
Okay, thank you. Fabio, there was a question posed to you in general today because you were mentioning the left and right looking data sets that they could actually help to uncover, let's say, the north-south deformation and going to do a 3D deformation. Someone mentioned, I think, Tavakolishnati, hopefully I say it right, mentioned that Tim Wright had a paper in 2004 where it showed that combining both left and right looking data leads to an ill-post inversion problem. Sure, because of having near polar orbits. But did we evolve since then on this, or because now we'll eventually be getting now more access to left-looking data, and we will be swamped by it maybe indeed. Let's say having Nysar coming up and.
Yes. I read this answer, but basically I think that on let's say on lower latitude, the left-looking on polar orbit is going to help less, but on temperate latitude is going to help a lot. I don't know. I calculated that in another paper. That's basically by and large it's the same thing as Tim wrote, but the numbers are completely different. In other words, you have a it's much better than the offset. So it's an order. I think it's an order of magnitude, but anyway, an order of magnitude better than the offset tracking.
Exactly. Yes, of course. Yeah, of course. This I would expect. Yes. Yeah. Okay. Thank you. There was a question from Dave McKenzie that comment that every additional processing level provided to the end user at significant cost and maintenance to compute and serve to the user. There is, however, a lot of value in providing additional metadata and single meta layers that would really ease the use of the data for many users. For example, co-registration offsets, unique burst identifiers, byte offsets within zip file, etc. And I think this is especially the way we see a lot of let's say data providers moving, let's say, and as well within InSAR we are as well moving in that direction. So this is indeed something that we are trying to take up, David. Okay, thank you. We're going now further to the next part, let's say, which is on data products and services. I have to say that we are going to move a bit over our allocated time, so I hope it's fine with the audience. Mario and Paulo, please, you have the floor.
Paulo, please start with the description if you want.
Paulo, you're still muted.
You're
okay.
right. Thank you. Sorry.
Excellent.
So the summary is very, very short, not because the presentations were not interesting, just vice versa, but beside the presentation about the new developments with the SNAR toolbox, so continuous development with new features, all the other presentations were focusing on the same topic. So basically, what we actually already touched in the discussion up to now, so the provision of analysis-ready data. from slightly different aspects, but in general, indeed, also because of the Fringe conference, they were mainly touching the provision not just of, let's say, more conventional amplitude time series or analysis ready data, but interferometric or something going toward interferometry products. So being them geocoded SLCs or wrapped or unwrapped products. So something that is going toward higher level products already made available in an automated way to the end users. And indeed, they showed also products easily derived from these type of pre-processing. And somehow they discussed, also they touched the point, well, what is the limit? Is this providing single burst products, geocoded single burst, SLCs, so that it's easy for the users to generate from them interferograms, or going a step forward toward providing full frame SLCs, full frame interferograms, unwrapped products, and so on. And I think there was no real consensus on these. The main point was at least all the presentations recommended going a level higher toward providing yes, geocoded interferometry ready products. From these, maybe we go to next slide. And basically there were two questions and recommendations to ESA. So well, the first is already touched in the discussion before. So is there any plan by ESA to go in this direction, so to provide higher level InSAR products? Okay. And the other question was, is there any plan from ESA to ease the access to single burst products? So now we heard there is the plan of ESA to provide IDs to identify the single bursts, but still users have to download and extract the full frames. So indeed, it would be extremely beneficial for everybody to be able to access in their archives single bursts products and not full frame.
Or do you want to discuss the questions right now, or you want to go to?
I think well,
yeah.
Probably is easier if we discuss these now.
Okay, because you have as well seed questions coming next. No, this is
yeah.
Okay. Yeah, fine. Okay, understood. Yeah. Okay, so on the higher level InSAR products, I think mainly, let's say, the trend is that for me is that we are providing, especially, let's say, tools and software and community software that's able, let's say, for the community to generate, let's say, this type of products, instead of serving it, let's say, directly, let's say. And I think one of the reasons is, and I think it's also mentioned by Ramon, that if you, let's say, there are different flavors of doing this, and by choosing only one, you will then be able to say, yeah, it may not be the right choice, or you may have to go back to this at some point. After the and the second point on the providing, let's say, on the downloading of Sentinel-1 single bursts. I think right now, of course, already, let's say, the IPF, let's say, the PDGS, the Sentinel-1 ground segment, is already moving into cloud, and I think this is will happen as well in the future to other, let's say, ESA missions, where it would also, you could also envisage that also, let's say, the user, let's say, will also be able, let's say, to get close, let's say, to the actual data sets itself as well in a cloud data, let's say, environment. And as such, then you would see that would most likely be a possibility. But the direct download, let's say, to the user directly, this is something that I would not directly foresee, at least not for the foreseeable future. But I could be wrong there, because I'm not directly involved in Sentinel-1 PDGS. I'm not, so maybe some of my colleagues can add there on this topic if if they know more about this.
Thank you. So maybe
Hi, it's Marcus. I don't have an answer to your last question, Björn, but just also for preparation for the future missions discussion on Friday. So I think that we should think about this higher level InSAR product question together with having several systems operated as a system of systems like Sentinel-1 and Roselle and Sentinel-1 next generation and Roselle. So what is the current thinking on how should this be achieved, or how does the putting on more SAR missions in this very similar geometry or even different geometry, how should that be taken into account when we consider higher level products?
This was a general question, Marcus, or a comment?
Yeah, just to pick everybody's brain also before Friday, and if there are quick comments, let's hear them.
We can take it up there in that other, let's say, Q&A session. And I agree, yes. Yeah.
As I mentioned earlier, we are planning to distribute higher level geocoded unwrapped interferograms for Nysar. So that's should be available in 2 years. We're building that system now.
Yes, and of course on the ESA side, of course, we're looking into different things as well to look at, let's say, at higher level products and even InSAR products. But these are, let's say, more on the R&D activity side, and of course there's no plan as such right now to have this really delivered to the end users because it's simply, let's say, simply in the R&D stages. Paulo, can we move to the next to the seat questions?
Yep.
Yes, please go ahead.
So one of the points that actually came out of the presentations and also from our point of view is about standardization and consistency. So if we can consider in the future having different data providers providing analysis data ready, how to kind of guarantee the standardization, the consistency of the products across different providers. So who could be in this position, so CEOs, or what could be the products so considered as best effort products, or should we expect products fulfilling to be defined standards on that data accuracy? So if the idea is to simplify the work of medium expert users, less experienced users, I believe providing kind of certified data would be in a way very important. I mean, else we heard already there could be problems in receiving data that are not as accurate as one would expect. Is there any comment on this?
I have a question from or a comment from John Deal. John, you can speak if you want. I'll mute you.
Yes, just going back a little bit to the idea of being able to download individual bursts. While that would be nice and perhaps isn't realistic in the short term, what about access to products based on which burst they contain? So now that this unique burst ID is available, we should be able to search on that burst ID and download all products containing that burst. And in that conjunction, will you be indexing all the historical products back to 2014 to provide some way information about which bursts they contain? In other words, generating an index similar to that being done in-house by Descartes Lab.
Yeah, I'm not aware of why that's going to happen as well for historical data, but I could be wrong there. But now I think you have to assume that this is not going to be done, let's say, for the historical data sets.
Okay.
But okay, this is as I said, I could be wrong. This is what I picked up, but yeah. Going back, let's say, to the seed question, I think, of course, in CEOS, they're of course trying to, let's say, at least open the room towards ARD by having, let's say, some groups working together to try to establish something in the CEOS framework. But of course, in the end, CEOS is of course not a provider, will not be, I believe, not a provider in the end, but may help towards standardization of some products or help also space agencies to think towards this type of towards this data. I think in the end, let's say, analysis ready data is of course something that should not be seen as best effort products, but really something to try to open up, let's say, a much larger community of people that are not necessarily people that are SAR specialists or even don't want to understand, let's say, what a wavelength is, or frequency, or phase, or fringe, as Howard mentioned, but to really people that are, let's say, more close, let's say, to the geophysical application area. And there, I think the analysis-ready data will definitely help people to really do directly science with data instead of having to become SAR expert and really fully understand the ins and outs on the instrument side and on even understand, let's say, that this is a spaceborne remote sensing instrument. So I think that we're moving in general. There is a tendency to move towards this, but of course it doesn't rule out that still the lower level products are still being consistently being served to the users.
Maybe I would like to say that I already said a little bit something in this direction before. The question, someone mentioned certified products. Products with the guaranteed quality and so on. So analysis ready data, in my opinion, are good if we can be sure that there are no big errors. For example, co-registration, you cannot have usually big errors. The same we already said for focusing. I would be, in my opinion, would be very risky to provide unwrapped phase, because unwrapped phase is a mathematically ill-posed problem. You can have big errors. So, cannot, in my opinion, the technology is not a good idea to provide this kind of products. There are, different type of processing that some of them are safe, some other not.
Bjorn, another comment or question from Piyush Agram. Piyush, you can talk. Thank you.
I think, yeah. I just wanted to point out that the ability to download individual bursts and the indexing of historical data has already been done by Descartes Labs. And if InSAR is interested, we would be happy to help if that is something InSAR wants to pursue.
Okay, excellent. Thanks for clarifying this. Yes.
So maybe we can move to the next.
Yes, we'll move to the next one. Yes. Here you go.
So if you like, this is a kind of a bit provocative question. So we are saying, most of the people are saying, well, yes, we expect analysis ready data are going to help people. So does this mean that users will be ready to pay for this data or adopt this data again as usual only if the data are provided for free?
And I was curious whether your team has had a chance to dig into sort of.
Yes, was that somebody trying to answer, or?
Well, it's a question we are posing to the audience.
Yeah, I understand, yes, but I heard some background, let's say, so I thought somebody was answering or trying to answer this, but yeah.
I can certainly answer for NASA point of view. The NASA has never always been in favor of free data products, and we think that higher level analysis ready products are something that we should be providing directly for free, at least for NASA missions. I can't speak for ESA.
It's clear, Eric, because there will be analysis-ready data developed from the ESA perspective, of course, then we will also, let's say, offer this for free. As you know, let's say our data policy is not so much different than the one you have at NASA. So, but of course, there is, of course, an entire value-adding industry that, of course, may be of interest, let's say, to develop as well. And this, of course, also of interest to the agency to develop, let's say, within Europe, let's say, the remote sensing industry. And as such, the application-ready data there may be an interesting commercial avenue to be taken there that could be of interest there. But initially, I think the application-ready data is something that I think the space agencies will have to try to uncover first and try to see if there's a need, a larger access to an end-user community to be enabled by this. But of course, it doesn't stop, of course, any value-adding industry to step into this because it's clear that as from ESA, let's say, we'll not be able to cover all the different types of, let's say, analysis-ready data you could consider for because even you could see some of them may be quite application-rich, but some may be as well very much, let's say, application-dependent. So I think there is an entire rich, let's say, feel that there's a landscape on different types of ARD data that or ARD products that can be developed. So I think it's kind of an open question there, Paulo. So I think we have to move on. I think in general, I think this.
No, and it would be interesting to hear the opinion of the end users.
Of course,
case,
yes.
Because, well, we speak from, in a way, same side. So Mario, maybe you want to continue with the.
Maybe can I make a comment on this? So I think if we talk about analysis-ready data, or if we don't talk about the quality of the results, then we have to keep in mind what actually the application is. And so, if, for example, if you have a mission that measures the biomass of the entire planet, then basically you have one parameter which is pretty well defined, and you can kind of distribute that final product. However, from my experience, what I've seen both in science as well as in industry is that for the deformation type of products from InSAR, it's a pluriformity of applications, which reaches from, let's say, somebody interested in the subsidence of his house, or somebody interested in the subsidence in a piece of road in front of his place, to an oil company looking for what happens if I inject something here. So in other words, there are many applications with the same data. And if, in my experience, if you want to do this good, if you would like to satisfy a final either customer or an end user, then you need to know what that party is interested in. And if that is well formulated, then you can come up with a great product, and InSAR is fantastic. But if you say, well, we just want to provide analysis-ready data without knowing what the application will be that end users will use it for, then it will always be suboptimal. And I think this is what distinguishes a lot of the applications in InSAR, at least for displacement analysis, from a lot of other types of, for example, optical remote sensing, or looking for biomass or so. I think that is a distinction that we need to make.
I don't necessarily. I mean, I partially agree in the sense that I fully agree that well, deformation products don't exist. I mean, you want to have deformation products for this, that, and another application. But the same, from my experience, applies to any type of remote sensing product we can provide. So if we speak of digital elevation models already, that in a way is one of the simplest products we can consider. Then you have, I mean, digital elevation model, digital surface, digital terrain. You have hydrologically corrected DMs for, I mean, landing purposes, or for hydrological, for geological, and so on. So already in that, I mean, very precise context, a single product good for everybody, I don't think is something that is really of interest for everybody. So indeed, I have my opinion to this question, and that is, I also don't believe we are ready or we will ever be ready to provide standard products good for everybody. And we do a single step, but then we leave, I mean, if I compare the complexity between co-registration and time series unwrapping or inversion and so on, well, we leave the most complex step to the end users. So I don't have the impression we are doing a significant step forward in helping the end users, providing just a little step more. But we are not in a position of solving all the problems for all the users.
That's absolutely clear, yes. Yeah. Okay, so we move to the next seat question, a couple of seat questions before I think we have to move on as well after, because we have still a Francesco session to cover. Yes, please, Paolo or Mario. This was also part of your session, I think.
Yeah. So, well, this is in a way concerning the type of products or the focus of the end users. Is there really a large interest to have large area products, or are the users more focusing on their local? Most of the users, are they focusing on their local area of interest? So in this case, is it really important to have systems capable of delivering large area products? Or is, on the other side, more important the consistency of the product? So if I order a product over Germany and the next day over the Philippines, do I get the same level of accuracy, the same type of product or not? Is this more or less important compared to, am I able to order a product that is covering the whole of Europe? And indeed, being able of ordering analysis-ready data impacts on the policy of, for instance, availability of Sentinel online, offline, and so on. So if I have a nice system capable of providing me time series, I need to be sure that I can access the full Sentinel-1 time series. It's not just limited to the last 1-2 months.
Okay, is there any feedback on this also from maybe from the panelists?
It seems to me that there's end users with a wide spectrum of different interests in types of areas. So that's something that you can't make everybody happy.
Exactly. I think this is indeed what we understand with the with ARDs as well, with respect to starting from a low level product and develop it, let's say, for the specific application end user, let's say. Yeah.
But we've been thinking for Nysar is that getting to a level 2 geocoded unwrapped product, it may not be perfect, but at least it's something that people can use to get a basic idea of what's going on before they want to do a more detailed analysis. That we think that's valuable, and that's why Nysar is planning to do that systematically.
Okay, that's an interesting addition. Yes. Okay, suggest we move to the last seat question from your session, Paolo.
Mario.
No, this question is, because we are going toward higher level product, but what the final user are really interested in is information, out of the box, high level information. So maybe the question is, there is need and someone will really exploit this platform, these intermediate products, or there will be a jump directly to the final information for the users? For example, in GNSS, we have seen that for course for course positioning, we have everything in our mobiles and so on. But when we speak about millimetric positioning or centimetric, okay, we still have specialized commercial services. And actually, I saw that these commercial services are growing. Surveyors now, there are companies that provide services to the surveyors for their surveys and so on. No one of these professionals go to play with platform or intermediate data. They just buy the final information. So, but really, this is a question. So, I don't know.
Well, we do have higher level GNSS products that are produced by the EPOS, what's that, the European Plate Observation System, or the North American Earth, the data systems. There are some systematic processing for scientific purposes that is done systematically. We haven't been doing that for science purposes. I don't think there are any scientific, although there are groups like Comet that are starting to produce systematic interferometric products. We also have a pilot product produced by the ARIA project at JPL for interferograms, geocoded unwrapped interferograms for a few areas. I think people want to have, until we provide some example products, people really don't know what they want. So it's important to give at least some examples for people to look at. So.
Yes, I think you're right, Eric. This is something, of course, this is an area where we have to, let's say, develop a bit, let's say, what we believe the end user would like to have in terms from our perspective, and then from there on, we hope that this community or the data will actually start flowing. So I would definitely agree with you there. Yes.
So I think the data are already flowing. Huh? So the main question is in which order you want to do things. I think the successful order is where end users define what they want, and then there is a party who can satisfy that need because that party knows what they want. So if we are going to have an overall discussion here of what the users want, we are never going to get an answer, because every user wants something different, and tomorrow the same user wants something different from today. And that's how the world works. It's not a problem, which is great. So I see this very positive. Unless we are really trying to come up with a product that will now satisfy the questions of all the users from today and tomorrow, that is not going to happen, right? So I think we're too negative here. So the methodology and the technology is very mature. It works, so similar like Mayo is stating, but it works in the cases where the problems are defined, where you are interacting with an end user, and that end user tells you what he wants, and then there are expert parties who can offer that information. Right. So the second bullet here is the InSAR technology mature enough to provide critical information such as stability of infrastructure or landslide hazard without specialized service providers. The InSAR technology is mature enough, right? Because there are already many of those service providers around, and they're successful. So I don't see any problem there.
No, but the question is without service providers.
I understand. So the question is, do you see this whole thing as a kind of black box where the computer takes the data from the satellite and gets it all the way right to the end user, I think that will not work. You need specialists. This is why we also at universities, we train students to be remote sensing specialists, and they can help these final users. And this is, let's say, the ecosystem in which we work. So if we start seeing this thing as a kind of black box without specialized service providers, so without adding the knowledge to the problem, then I think we're barking up the wrong tree. We need the data, we need the flow, we need the technology, but we also need experts who can help end users to answer the questions that they have. But the order is first they ask the question, and then you apply your technology and your data to satisfy that question, not the other way around.
In my opinion, the point is reliability of the information we provide. And this is also a risk because, you know, InSAR has become quite successful, but now there is the risk that we could destroy the credibility if we end up giving wrong information to the users, because till when InSAR was for specialists, for the academy, then okay, if some result was not perfect, some information was not good, okay. But if you go to a geologist that has to make an investigation to decide where to build a house or a bridge, you provide wrong information, then after you do so, they will not believe you anymore. They will not believe InSAR anymore. So there is really the risk to provide wrong information to the final users. So that's why I think that you know, the final user wants reliability in the information, even more than accuracy. And providing products, higher level products, which are not reliable, it's risky.
Yeah, I agree. We have to provide error estimates for any data product. So if there are higher level products provided, they have to have an error estimate that provides what the uncertainty is.
Yes, this is this is of course a valid point. Yes, but also to say the one thing is talking about, let's say, about ARD data, let's say, of supplying, let's say, users with let's say higher level data, let's say high level information. On the other hand, let's say there's also of course another trend is supplying users, let's say, with tools or with generic, let's say, scripts or to develop their product, let's say, with some example data, let's say, to actually follow it through, let's say, more as a where you actually will be able, let's say, to instead of having people, let's say, to develop everything by themselves, that they actually will be able, let's say, to use software tools or software environments, even in a cloud infrastructure, to develop something as well. So I think these are trends that are the two different streams, of course, and they're not competing. But they will help to let's say let the community even further grow. And when I was saying, let's say, the data will be flowing, I'm not saying that the data was not flowing right now, of course, because definitely data is flowing. But there is an enormous potential of using, let's say, this data beyond where they're being used right now. And I think this is what we all understand as well. Okay. Yes.
In the interest of time, I think that there's still more questions from this session because we are running over time.
Yeah, we have only Atmosphere and Ionosphere to go, let's say. So there's Francesco. So we're going now to the next. This was the last one in this session. So then we go now to the one from Francesco. If Francesco's still around, hopefully, yes, he is. Francesco, yes, you're there.
Yes, I'm here.
Yes, please, Francesco.
Can you hear me, right?
Yes, we can hear you fine.
Okay. So next slide. I'm trying to summarize quickly the session. The session is on. It was called Atmosphere and Troposphere, and basically Ionosphere and Troposphere. So for the Ionosphere, basically, I would say we see GNSS models are very useful. I would say, especially for geolocation and at C-band. But we should not forget the top part of the ionosphere. Heresh Fatai was showing a very nice solution using the GNSS on board to estimate the part of the ionosphere which is on top of the satellite, so that he could correct GNSS-based models to take this part out. Things will become more challenging for L-band. Geolocation residuals scaling up experience from C-band will go around 1 meter in range. In azimuth, I don't think we discussed it, but it's worse. There was a presentation by Virginia Brancato on the challenges of the split spectrum using this quasi-quadpole mode, some sort of hybrid thing for Nysar. She was showing that, so the recommendation here for Nysar and for everybody else, don't do this quasi-quadpole mode if you want to do split spectrum. This cross-pole phase is often biased dozens of degrees, so the split spectrum will not work properly. If nonetheless this mode is selected, the recommendation is then not to use the 5 megahertz special bandwidth for the split spectrum, but to split the main bandwidth. The 20 or 40 megahertz bandwidth is still better. So you have, of course, a degradation. You lose the purpose of having this special bandwidth there for the ionosphere, but the performance will be better. So this is my understanding. Then maybe if you click, you get, there was a little animation. You get a second. Yes, thank you. For the troposphere, there was a presentation by Masato Furuya from Japan on showing who was showing with L-band data that we have possibly some dispersive effects related to heavy rain. And this is of course a challenge in case this is not very, it's a rare event probably, but it will bias a bit the split spectrum results. The physical nature is still to be clarified. There are several ideas, but clarification could come looking at the same phenomena with higher frequencies, where these effects could be stronger or smaller depending on the nature of the effect. I would say also we have seen a lot of, so we see that the global weather models are used now well to correct SAR in general, both geolocation and phase. And we had a presentation on how to improve this high offset estimation, like the absolute delay estimation from the troposphere to ingest this into weather models, because of course we have all these relative measurements. We need an offset and how to do it properly. Improvements in this line. So next slide. Thank you. So putting everything together, so the tropospheric, ionospheric, solid earth tides correction, instrument corrections, we have seen in both presentations by Christoph Giesinger and Heresh Fatai that we can have sub-decimeter absolute accuracy for Sentinel-1. This is the message I got. Somehow, sometimes even better. Interferometric relative error, I can tell you they can be even smaller internally in a scene. And this extended time annotation dataset product, this provides all the correction layers, all independently, so they can be also turned on and off at will. And I think this could be very useful as a Sentinel-1 core product. And for what I understand, this is at the moment not possible to have. Next. For the For C-band, I think I can also say from experience, but it was also said in the presentation, we can do blind co-registration. And so the natural continuation on this line would be having co-registered stacked products for C-band. There was a note that this is the large data amount is still a challenge, and I will not repeat here that I think that the phase product would be an answer to this large data amount. Maybe next, I was trying to come up with a couple of questions. I'm trying to interpret a bit what could be the future here along this line of corrections and all this. And so I'm asking if do we have to go towards SAR-based operational corrections for the ionosphere? On one side, anticipating for L-band, because GNSS-based corrections will be difficult more, both for geolocation and for InSAR, of course, where we do split spectrum. And maybe even for C-band InSAR, do we think we need this? Operationally, in the sense of having it in some ground segment, because we have many groups now have this operationally. Another question is, are we then really done with the troposphere? So are we, for geolocation and phase applications, are we satisfied with what we have, ERA 5, at the global scale? Or is there anything else that could be studied? And I'm thinking, especially because it's natural to say, okay, if we have a lot of GNSS, you can use GNSS, of course. But where we don't have GNSS stations, where we don't have enough density of GNSS stations, is there anything else we should study? And then I have another topic. Since there are applications that benefit from having absolute motion. For these applications, you can sometimes reach, as we have seen, decent performance, and there's no need for unwrapping and this kind of line of thought. Is what do we do with L-band? Because we were starting to investigate, but we have not finished, let's say, to investigate the potential of using absolute ionospheric delays, so to unwrap and solve the ambiguities at the also at the ionosphere of the ionosphere contribution to reach really, I would say, the centimeter level at L-band. So because I think in the range direction at least, because I think at L-band, all this kind of applications based on offsets and all this, they are severely limited by the ionosphere. So this is, of course, difficult. Maybe it will put some requirements on the instruments or on the processing, because we are getting very sensitive to systematic disturbances. But maybe it's worth looking at it if the application side sees a potential here. So that's it. So these are my questions.
Thank you, Francesco. I think that was very useful. Maybe for the first, maybe I can already provide an answer. Let's say for. I think we have to at least have to understand whether this is especially needed. So for L-band, definitely, let's say, I think we have to go in that direction, and even for C-band, as you say, we may have to be able to. We may want to even think about possibly flagging, let's say, acquisition where we believe, let's say, the ionosphere perturbation is let's say, to a certain significance that it can affect, let's say, InSAR applications. And I think it's in general it goes, let's say, to let's say the same way how we're now, let's say, dealing as well with the troposphere corrections. That this is something that we are consistently pushing the envelope, and as such, let's say, we are trying to get the best quality data out of the chain as possible. And as such, we have to take into account more and more, let's say, corrections that we want to take on board, and in the end they will very likely end up this way as well in let's say possibly as well even in the operational processes, but of course this will take time, but I guess we are going in that direction in general, I think so. So this I would say is quite affirmative, at least to the first overall question that you have there.
But it's I see implications again related to the phase, because for example, so you could provide some intermediate thing. Of course, it has to be reliable enough. I understand it. This is part of the game. One could some intermediate thing like group delays and phase delays, let's say. But there's also a problem providing the final split spectrum product, because in the middle you need, well, you seem to me, at the moment, I still think you need some phase unwrapping. There was a proposal by Urs Wegmüller, I think, to avoid phase unwrapping, but and then this is where things become more difficult, because yeah, maybe having some expert looking at the unwrapping would be good. So I see it, because these things are no longer single image based, like the ATAT corrections, which are just every image gets every acquisition gets a correction. These things are relational in nature, so they are a bit more complicated. Yeah.
But the fact that they're more complicated doesn't mean that we should stride away from them to trying to make it to increase the quality of the product. So, but indeed, it will take time. I agree with you. Let's say to try to uncover, let's say, the way how that should be done in general. For the troposphere part, is there any? Are we happy there? Is basically what you're saying is for geolocation InSAR applications. Is this maybe I'm not sure if Ramon, if you want to answer on this one, because if you're still around.
I'm still around, yes.
Yes.
So the question is on the troposphere.
Exactly. Yes. Yeah.
Yeah. So I think indeed we reach a kind of point where we do not really get much further with the additional data that we have, either from weather models or from GNSS. So typically, if we have more GNSS stations that we could correct for the atmosphere, then actually my statement is that we would not need InSAR anymore, because we have already so many GNSS. So then we make ourselves superfluous. But what we mainly see is that for the let's say the turbulent parts of the atmosphere, so the convective atmosphere, which contains very large displacements, or let's say compared to big displacements over very short distances, that is difficult to estimate, simply because models do not really predict where a cloud is at a certain moment. And if there is a drift, so if that particular convective cell is at a different location, then we basically amplify our analysis or our results if we correct with such a shifted product. So we're reaching a kind of limit here, in my opinion, where we cannot go any further with correcting the realization of the atmosphere at that particular time, and we need to go to more like a stochastic description of it, using structure functions or variograms that describe the variability of the atmosphere for a certain location and for a certain point in time. So I think we're reaching a limit here.
Yes. Is there anything, let's say, else that could be studied? Of course, we had, of course, in the past, where let's say there's been quite some attempts looking at this, let's say, both from a numerical weather prediction model perspective, but also, let's say, from the InSAR data itself. and using in the past, let's say we were as well trying to use Maris as well in this combination. Is there anything else if you look at, say, at the future? Also, let's say looking at what is coming ahead of us. Say, is there anything we can study there beyond what we've already been doing? Is there?
Yeah, well, honestly, I don't see that much opportunity.
Exactly.
So the collocated measurements with different sensors, of course, that's great because if you have it at the same time. But the problem with Maris was always that if you have it, you don't need it, and if you need it, you don't have it, right? So if there's a big cloud cover, then the optical data don't see the lower parts of the atmosphere. And if there's a lot of cloud cover, then often it is convective and you really need it.
Yes.
And it works very nice if there's almost no cloud cover and you can see the water vapor over the clear atmosphere, but then the signal is not so big, so then you don't need it. So yeah, I don't see the let's say the steps for really big steps forward.
No. And I think we reached a certain level of maturity there already. I think that's which is already not too bad, but that's maybe. Maybe for next Fringe we may come up with something new there.
Maybe somebody in the audience has some smart ideas.
Yes, of course, yes. Are there any questions still, or on the last part of the ionosphere delay to reach centimeter level at L-band is this is something for Francesco. What do you think? What can we say there, according to you?
I don't know. I was trying to ask also JPL colleagues, and if we go to L-band, and we like these offsets, and maybe we have to see if this is possible really. And we were trying from the technological point of view, but I'm not sure if from the application is it needed and the same if there's a push or a pull there.
Yeah, obviously this is something that we're working on very strongly for the Nysar mission, because the L-band ionospheric delays are very large, especially when we start moving towards the next solar maximum. At the high ionospheric levels, we might have range delays on the order of 8 meters on high ionosphere days. So that's something that has to be corrected for geolocation. You can't have an 8 meter geolocation error, even for the people that are studying vegetation. So that's something that we are looking at, where we really need to have a global network of GNSS stations to be able to measure this, especially some places like Africa, where there are not adequate spacing of GNSS. So we're even looking at trying to get some new stations installed to be able to measure this more accurately. Because the absolute range delays are very large from when we get into the L-band.
Just to be more specific, the thing was, oh, sorry.
No, I was just going to ask, are there still more pages of questions?
No, this is it. This is it last.
No, that's it.
Right, so we need to wrap up soon, but yes. Okay, good.
We are aware, Marcus. Yes.
I'm soon alone in Esrin.
Francesco, yes, sorry, you wanted to say something.
No, just to clarify, this maybe the question is a bit cryptic, but the idea is that if you have 3 bands, we can do something here. Like it's possible to potentially it's possible to get some good corrections, but maybe it has implications for the instruments, for the processing, for the focusing. One has to, and I don't know. So I was just to throw something in. So.
Yes. Yeah, but anyway, we know this is not easily going away. I think we have to deal with this, let's say, as well. And the good news is, of course, that L-band data will become more and more, let's say, superfluous, let's say, in the years to come. So yeah, there will definitely be attempts to keep on working on this to get a better grip on this. Yeah. Okay, thank you. I think with this, I would like to close this technical session. Thank you all, let's say, for your participation, and apologies for the delay. I think we had some interesting discussion, and since we had to try to summarize 1.5 days of Fringe, I think it was definitely not something to be done, let's say, in 1 hour and 15 minutes. So
yes,
thank you all. Yes.
There I'd like to remind the chairpersons that you have to advocate somebody to present the summary on Friday, so not everybody can start an early weekend.
Okay, so thank you all, let's say, and have a nice continuation of your day, and looking forward to the remainder of the week with a very interesting presentation at Fringe.
Great.
Thanks to everybody.
Thank you.
Thank you.
Thank you.
Thank you.
Bye-bye.
Thank you.
Thank you, everybody.